All right. Welcome, everyone. Welcome to NET217. Hope you're having a fine re:Invent so far. Hope you caught the keynote this morning. My name is Adish Bhobe. I'm a product manager with AWS. I have with me Matt Engskow. He's a principal engineer, and we are both from the Amazon Route 53 team. We're going to talk about a new launch that we just released a couple of days back called Amazon Route 53 Global Resolver. But before we begin, just a quick show of hands in the room. How many of you are network administrators who dabble with DNS security? See quite a few hands raised. Great. Well, you're in the right session because we're going to talk about how you can achieve secure and also anycast DNS resolution for your clients with Global Resolver. So this is what we're going to talk about today. We're going to talk about what are some of the key challenges that got us here. What are some of the things that we heard from you, our customers, that led us to building Global Resolver. We're going to talk about why you should use Global Resolver and what are some of the key benefits that you're gaining from using this service. Then I'm going to turn it over to Matt, who's going to walk you through how you can get started and how you can use this service in optimal fashion. There's also going to be a cool demo, so stick around for that. We're also going to have a case study where we're going to talk about how Just Walkout Stores uses Global Resolver and how they plan to scale it across all of the stores. For those of you who don't know, Just Walkout Stores is a technology built by Amazon for all of its stores, including Amazon Go and Amazon Fresh, that allows for cashierless and touchless user experience. And then I'm going to end it by talking about where you can use this service, in which regions it's available, and also give you a glimpse about the pricing. So at the outset, I want to talk about the three key challenges that we heard from our customers that led us to building Global Resolver. First was split DNS management. What we heard from our customers was they were maintaining forwarding rules for different customer locations, for different data centers, for different branch offices, and even for the remote clients, especially to allow split DNS between private domains and for public domains on the internet. In case of AWS specifically, this meant doing split DNS management for private hosted zones, which is nothing but a container of domains and subdomains that you can use for your private domains hosted on Amazon VPCs, and also to split traffic to an internet domains or for internet applications. At the same time, there were requirements to have different DNS resolution views for different sets of clients. And this added a lot of operational pain for a lot of our customers who had to maintain these and make sure that those are consistent across all of their locations. What we also heard from our customers was the ability to prevent DNS exfiltration. DNS exfiltration is a mechanism that's used by attackers today to exfiltrate data over DNS. And this is a key requirement for a lot of our customers who today are using appliances on premises or setting up their own custom rules to ensure that clients are not talking or resolving traffic to any malicious domains on the internet. At the same time, there are requirements to meet compliance needs and audit needs to have all of the logs in a single location for easy auditing and compliance. Now let's take this setup of split DNS management and also maintenance of all of your rules across multiple regions and multiple customer locations. This can get very tedious and it can get very cumbersome for your teams, especially when you have to replicate the same rules across multiple different locations. Ensure that they're consistent, up to date, and that all your clients are resolving the same set of domain rules or domains that you want them to. At the same time, ensuring failover between all of these regions was another key requirement that we heard from our customers, especially for continued DNS resolution. You may have clients or you may have applications that need high availability DNS resolution and resilience at all times. And so with that, we are launching Amazon Route 3 Global Resolver. This is available in preview today for you to use. Global Resolver is an anycast DNS resolver that provides you a way to resolve both private domains hosted on AWS as well as public domains hosted anywhere on the internet. At the same time, it allows you to filter traffic to any malicious domains, encrypt traffic in transit, and also log all your queries across all your locations in a single region, in a single place of your choice, making it easy for you to access those logs. Global Resolver is optimized for latency, so it will always route your traffic to the closest available region that you pick. It's also optimized for resilience. So in case your clients are not able to reach a specific region, it will automatically fail over to the next available region. And it's also built for data residency needs. We'll talk all about this in the next couple of slides, but I want to give you a glimpse of how it all looks when it comes together. Here, you can see that you may have multiple corporate data centers, you may have remote locations, you may have branch offices. With Global Resolver now, they can all point their traffic to a single Anycast IP without you having to maintain separate forwarding rules in every location. Global Resolver will be available in the regions that you pick and will be able to process your queries for both private hosted zones as well as any queries going out to the internet based on the filtering rules that you set. Next, I want to talk about what are some of the key reasons why you should be using Global Resolver. And this goes back to the challenges that we just talked about. With Global Resolver, you can achieve split DNS management. You can resolve both public domains as well as private hosted zones from anywhere, from all your customer locations, wherever they are. This provides you an easy way to quickly resolve all your traffic and simplify all your rule management across all your customer locations without you having to manage forwarding rules in every single location. It's internet reachable. Global Resolver Anycast IPs are internet reachable, so you can reach them over anywhere from all your authenticated clients. Which brings me to the next slide. Global Resolver is not open DNS resolver. This is only accessible by clients that you authenticate to use with Global Resolver. And there are two ways that you can authenticate your clients. One is using IPs. These are IPs that are associated with your clients, maybe your on-premises destinations or your branch offices or even your remote clients. You may also have clients that may have dynamic IPs, or the IPs may change over time. And in that situation, we recommend that you use access token secrets that we will vend out and that you can deploy in your clients. These will be more permanent so that even if your clients are roaming or changing IPs, they will stay over and authenticate with the Global Resolver. Once they are authenticated, all queries from your clients will be processed based on the rules that you'll create. I want to talk about another key notable feature of Global Resolver, which is the ability for you to have more flexibility in how you group your clients and your locations. So you may have different DNS resolution requirements for different sets of clients. For example, for your roaming clients, you may want to have DNS filtering rules. You may also want to have the ability for them to resolve private hosted zones. You can create a separate DNS resolution view, which is a logical grouping of all your clients identified by access tokens or IP groups, and then ensure that any traffic coming from those clients is treated based on the rules that you create. You may also have a different DNS view for different sets of clients. So with DNS views used with Global Resolver, this gives you that easy, flexible way of managing all your clients across different locations without you having to create different rules for each of them and managing them. Let's talk about how you can improve DNS security with Global Resolver. You will have access to multiple managed domain categories. These are pre-configured categories that are classified by both the type of DNS threats, which could be malware, command and control, spam, phishing, or even based on the type of web content that domain hosts. You can choose to block, alert, or even allow some of these depending on your requirements of your clients. These are pre-configured, so there's no management from you. They're automatically updated, and even as you vend out the rules to different clients, the automatic updates are automatically moved and propagated to all your rules and clients. I also want to talk about a key aspect of DNS protection, which is how you can improve DNS security for advanced DNS threats. There are two specific DNS threats I want to talk about. One is DNS tunneling, which is a way where an attacker can set up a DNS tunnel using a malware that's already pre-propagated to the client's device, and that malware is sending malicious DNS queries to the command and control server. Using a pattern of request and response, the DNS tunnel that is established allows the attacker to then exfiltrate data over this DNS request from the client. Another DNS advanced threat that we hear from customers is domain generation algorithms, also known as DGAs. This is where an attacker can create multiple domains, multiple bad domains, which could be in hundreds, thousands, sometimes even in millions, with the objective of evading detection. So that over time, even if threat intelligence feeds are able to catch these, the attacker has moved to the next possible domain and carrying out their attack. Again, with Global Resolver, you can create DNS rules for these advanced DNS threats. These look at anomalies in your DNS queries, such as length, the type of query, the query name, to make a probabilistic determination of whether the query is associated with DNS tunneling or DGA. These rules are also customizable. So you can set rules, for example, to block the most highly probabilistic DNS tunneling or DGA threat. Or you can set a rule at a low confidence to only alert on these threats so that your security teams can then investigate and make a determination of whether to block them. They are all real time. So all the monitoring is done real time and inline for all your queries. Besides DNS exfiltration, you can also improve your DNS security by enhancing privacy of your queries. And with Global Resolver, you have the ability to use DOH or DNS, which is DNS over HTTPS, or DOT, which is DNS over TLS, both known DNS protocols, to encrypt traffic in transit between your client and Global Resolver. This ensures that any traffic cannot be sniffed by an attacker in transit. And then a key requirement for a lot of our security operations team is to have all their logging for all the queries in a single place, which is also possible with Global Resolver, where you can pick the region of your choice, an S3 bucket of your choice, to store all those logs. All right, so we talked about simplifying DNS resolution. We talked about DNS security, access controls. Now let's talk about another notable feature of Global Resolver. Global Resolver is optimized for latency and also for region failover. Queries from your clients are automatically routed to the closest available location that you pick with Global Resolver. We ask that you pick at least 2 regions so that whenever a region is not accessible from one of your clients, will automatically fail over to the next available region so that all your queries are always answered with high resiliency. You also have the flexibility to use global resolver for your data residency needs. So for example, you may want to create a different Anycast IP for a different set of regions or a country, depending on your security mandates or organizational mandates. And based on the Anycast IPs that you create, your clients will be directed to the ones that are mandated by your organization. So we talked about the key challenges, we talked about the key benefits. Let's talk about the key scenarios when it makes sense for you to use global resolver. And there are 3 of them. First, global resolver is most optimal when you want to have consistent DNS resolution across multiple locations. So you may have multiple data centers, you may have multiple branch offices, you may have remote clients distributed across the world. If you want to have consistent DNS resolution and security for all of them, global resolver will provide you necessary rules and the flexibility to use them without you having to spend the time to create your own rules. You may also have disconnected sites. For example, you may have clients that are directly accessing the internet that may not be under the purview of your security teams or networking teams. Again, bringing them under a single Anycast IP with the rules that your team creates, they're always bound to resolve to the same domains that your team has set without them having to egress to any DNS location that is outside the bounds. And lastly, you may have critical clients or applications that need DNS resolution at all times. With global resolver, you have the ability to easily failover between different regions without you having to manage those failover options yourself. All right, I've talked about global resolver so far. I want to switch topics a little bit. I want to ask everyone in the room, how many of you are familiar with Route 53 resolver today? A lot of you, yeah. So as you all know, Route 53 resolver, this is the default resolver that comes with all your VPCs. It allows you to resolve queries for your private domains, hosted zones, and any internet domains. You can also forward traffic between your VPCs and your hybrid clients that are connected to the VPC using resolver endpoints. With the launch of global resolver, we are now renaming Route 53 resolver to be Route 53 VPC resolver for better architectural distinction and from naming perspective, consistency. I do want to highlight though that this changes nothing in terms of the API operations. You can continue using Route 53 resolver the way it is. There'll be no change over there. But I do want to highlight the key differences and similarities between these 2 products and also talk about when you should use global versus VPC resolver. Global resolver is multi-regional. It is reachable over the internet from anywhere as long as it's authenticated to use. VPC resolver, this is the default resolver for your Amazon VPCs and for any clients connected to those VPCs using resolver endpoints. Both global and VPC resolvers support encryption. Global resolver supports DOH and DOT protocols. VPC resolver supports DOH protocol today for any traffic between your VPCs and your hybrid clients. A key similarity of both these services is both of them use DNS firewall. This is a feature of Route 53 that is in use today for blocking any traffic to any malicious domains on the internet. In terms of positioning, we expect that you'll use global resolver for any remote networks, any remote clients, hybrid networks with a multi-region footprint. So you may have multiple regions, you have multiple locations that you want without having to spend the time in creating forwarding rules for each of those. VPC resolver will continue serving all your clients within your VPCs and also any clients that may be connected to those VPCs using resolver endpoints. All right, we have covered a lot of ground. I'm going to turn it over to my colleague, Matt, who's going to talk you through about how you can get started with this service and also the best practices.
Thanks, Atish. My name is Matt Ensko. I'm a principal engineer at AWS Route 53, and I'm incredibly excited to talk to you about Global Resolver today. The key takeaways that I want you to have for this section are, first, I want to give you a leg up such that if you want to use this product, you can quickly go back to your organization and put it into use. I want to get you familiar with the constructs that you'll be using under the hood to do that. And I want you to understand which you should use in which scenarios and how you might apply them for your network's very specific needs. To get started, we're going to talk through how we might set up Global Resolver using the CLI. If you're more interested in the console flow, we'll be going over that too in just a little bit as part of our demo. The first thing that I want to do when I want to create my Global Resolver is define the regional scope. So as we mentioned, when you make this create resolver call, you're going to be passing in at least 2 AWS regions that are going to be used to serve your DNS traffic. Optionally, you can also configure an observability region, where that observability region will be used to aggregate your logs such that you can review them later if you have compliance needs or you'd like to do some investigation about why DNS is working the way that it is. Once I've created my Global Resolver, I'm going to be given back a set of IP addresses and a DNS name for my Global Resolver. These are going to be static for the lifetime of your resolver, regardless of what other configuration you take. And they'll be useful when you start configuring your clients. Following the creation of my Global Resolver, I can start to define my DNS views. These DNS views are logical containers for all of my configuration, policies, and allow clients to access my Global Resolver. Now, by default, the Global Resolver has no access. Regardless of how I try to throw packets at those IP addresses or that DNS name, they're not going to work. So the next thing that I need to do is create a way for my clients to become authenticated. As Atish mentioned, I can do that in 2 ways. I can use access sources to take my known public IP addresses for my clients and configure them simply. If I have roaming clients, I might like to use access tokens and instead create these pre-shared kind of secret keys that I'll then distribute to my clients later on. Now, once I've created these, my clients can then start to use the individual views that have been mapped to these access tokens or sources. And it's going to be kind of vanilla DNS, just a public DNS resolver. But I might want to do more than that. So optionally, I can also start customizing these views. I can create things like firewall rules. An example that we have on the screen here is something that maybe your spouses or your managers might like to do while you're here at reInvent. I can block gambling for all of my clients. Additionally, I can associate things like hosted zones that allow me to customize DNS resolution for my own internal applications as I see fit. I can continue to layer these things on as needed and update DNS views later on as my policies change or additional private hosted zones become provisioned. Now, I've walked you through how to create your Global Resolver. I want to give you some best practices for those key focus areas that Atish mentioned earlier. So we're going to talk through some of the best practices for achieving split DNS resolution, securing your global access, improving your security, and failover and multi-region resilience. First, let's start with achieving split DNS resolution. So as called out, a single Global Resolver can be responsible for many, many views. You can think of the Global Resolver as just those IP addresses and kind of the networking setup, but how my clients actually get a DNS answer is a logical construct held by those views. Those views can take many different forms and can be customized to fit your needs. So I may have some networks that are very open, right? Clients that don't have very many restrictions. And I may have some clients that are maybe highly sensitive workloads where I need to lock down DNS and only allow them to resolve a very small set of domain names. I can put both of those into 2 different views and associate them to a single Global Resolver, and then map the clients through the sources or tokens appropriately to those views. How this might look under the hood. So maybe I start with DNS view A here on the left, and I might add in a couple of hosted zones. These can be the same private hosted zones that you already have for your VPCs or brand new ones. I may also create a firewall rule. I would then layer in my access source with the IPs as appropriate. Now, if I want to spin up a new view, maybe I have new resources, or maybe I want to reuse some. So you'll see in the example here, I'm reusing this top hosted zone, has the same ID, but every other resource below it is a completely new one. This allows us to quickly get to consistent DNS resolution without needing to provision new networking infrastructure where I want it, but to specialize those views where I want it as well. Next up, let's talk about authentication. At a high level, we have those two same constructs. We have access tokens and access sources. But beneath those, there are individual kind of protocol supports and some nuances that I want to talk through. When it comes to access tokens, you can use, first, DNS over HTTPS or DOH. When you're configuring DOH on your clients, you're going to be specifying a very specific DOH URI or URL that includes the access token to be passed upstream to Global Resolver. One of the nice things about this option is that it's supported by common operating system like Windows and Mac OS today. So you can go and configure those clients without ever installing a new client software or having to do much configuration on those. Another option for access tokens is DNS over TLS, or DOT. This is often supported by common DNS server softwares like Unbound, Core DNS, and others, and is a really good option if you have a centralized DNS forwarder for an environment that your clients are forwarding to first before you want to egress into Global Resolver. For DOT, we will be configuring that DOT client to inject an eDNS 0 option or a DNS extension that specifies a very specific DNS operation code and your access token, and can, again, pass it upstream to Global Resolver. On the access sources side, we support all three of these protocols, but in a bit of a simpler way. You can choose to use DOH, DOT, or the more vanilla DO53, UDP, TCP, DNS, so long as you're willing to configure those source IPs. This is a really simple option if you have fixed IP sites where you've got that list of IPs readily available and you don't want to go and configure client devices in any way at all. One important note here, your DNS views can use multiple access types as needed. So in the example here, you can see that view A has both an access source and an access token configured at the same time, and view B has only an access source. That's absolutely okay. You can mix and match these as needed. Additionally, each view is meant to scale to handle thousands of potential tokens and sources. So if you have many roaming clients or many sites that you want to configure, you can do that all behind one view or many views as needed. Next up, let's talk about improving your DNS security. Now, because we've had DNS Firewall, the same service that's used on your VPC DNS today, we've seen a lot of learnings from customers over time in the ways that they configure this service. There's a lot of configuration that you can do and a lot of customization. As Atish mentioned earlier, you can build exemptions for your trusted domains, enable those advanced protections. We can support both fail open and fail closed if you're more concerned with availability or security. And you can do both allow and deny by default in case you want to operate in that walled garden mode where perhaps you only allow a very small set of names to be resolved. I want to talk through how we've seen customers adopt DNS filtering and kind of the safe way to do it. So first, one of the things that we see many of our customers do that we recommend is to start with an allow list for your organization's highly trusted domains. These are the things that you know should never, ever be blocked. If you're going to be using the advanced protections that we have that are backed by some very smart machine learning models, we still recommend that you allow list your trusted domains, just in case you happen to be doing anything that happens to look like tunneling or DGA traffic for those domains, it'll still be allowed. We often also see customers who are willing to block for our most high confidence thresholds on those advanced protections, but maybe they still want to receive alerts for the lower thresholds. And so you'll see our priority values here allow us to do that. We can layer in our high confidence and then below that put our low confidence where maybe our security teams are going to be sifting through our logs and looking at those findings rather than blocking production traffic outright. Now, as customers adopt these features, we see them work through kind of a phased approach. It often starts where customers are starting with log analysis on their DNS traffic. They're looking for those highly safe, trusted domains. They're looking for things that might be spurious, and they're coming up with what they think might be reasonable rules. We highly recommend that customers start with alert rules, where in phase 2, you go ahead and start building out what may eventually become your production rule set, but you enable it only in an alert mode, where you can then go back to your DNS logs and see what would have been blocked had you turned these things on. For many customers, they cycle back and forth between kind of phase 1 of log analysis and phase 2, where they fine-tune their policies over time, and they adjust them until the number of alerts that they're seeing becomes very, very small. And they're confident now that they can move on to phase 3. In phase 3, you take a simple rule update, and you change your alert rules into actual block rules. And at this point, your traffic starts to receive those DNS filtering policies, and they become enforced. We still recommend that customers continue to monitor their metrics and their logs to look out for a new spike in blocks or a kind of new spurious traffic that might be being identified by the service. Your workloads are going to change. You're going to take new dependencies and update your software over time, and there will be some maintenance required there. All right, that's all I have on DNS security. Finally, let's talk about failover and multi-region resilience. Global Resolver is designed to offload the complexity of multi-region DNS deployments. The service works to protect your network from both internet, routing, and service impairments, and automatically redirect traffic to maintain that high availability. As called out, when you provision your Global Resolver, you get 2 IP addresses back. Behind the scenes, those 2 IPs are backed by separate, redundant capacity. And we always recommend that clients are configured with both those IPs, such that should there be an issue with one of those IPs, they can quickly retry and distribute traffic to the other. Now, that's pretty standard in DNS to have your primary and secondary. Let's talk about how the service works behind the scenes to maintain availability at an even higher standard. When routing into regions that you've configured for your Global Resolver, your traffic is first routed through AWS edge locations that are close to your client. There's more than 400 of these edge locations worldwide, and that ensures that they're always close by to your clients, regardless of where they reside. Now, what happens if one of those edge locations has a network or service impairment? Global Resolver's Anycast route announcements ensure that we are able to quickly fail away from an impaired edge location and onto one that can successfully process your traffic. Now, this same concept applies when it comes to our multi-region resilience story. So should AWS, in the rare case, be having an AWS service impairment in a given region, that secondary region that you've selected, or if you've selected more than 2, your clients will again be rerouted to the next available region. We think this provides a really robust story and helps automatically solve for your disaster recovery and multi-region resilience requirements that you might have for your services. All right, that's all I have for best practices. I now want to talk about a case study that we have covering Just Walk Out stores. As Ahish mentioned earlier, Just Walk Out is a technology that simplifies shopping that's been delivered by Amazon. It helps customers get in and out of stores quickly, where they can enter a store, grab what they want off the shelf, and get back to their day without ever having to queue or stop at a cashier. You might have used one of these locations at a sporting event, maybe at the airport, or even here in the conference center, where our merch store over in the Venetian has one of these today. The technology backing these uses a combination of cameras, RFID, sensor fusion between those 2 things, fast checkout registers that scan your phone quickly for payment, and all of those things require a very robust network. All of those network devices need DNS to function. Behind the scenes today, Just Walk Out has a very large distributed DNS footprint. They have over 300 of these stores across Australia, Canada, Europe, and the US. And these result in over 550 million DNS requests per day. To handle these, they provision infrastructure in 4 AWS regions. Now, pre-migration to Global Resolver, their footprint looks something like this, albeit a little bit simplified. On the left-hand side of the screen, you can see that they have a centralized DNS forwarder that's the first hop for all of those cameras and servers and processing devices. Those DNS forwarders are then sending into AWS regions, those 4 AWS regions, where they have a custom DNS server software that's doing a couple of things. For one, it's doing the IP allow listing. They're sending this over plain DO53, and they're IP allow listing each store that they build out with that fixed IP. They are applying some conditional both DNS zones where they have per store DNS records that they need to serve up, and conditional DNS filtering rules where they have a front of house and back of house network that have different security requirements. Once those rules have been applied, they were then forwarding into Route 53 Resolver inbound endpoints to help them get their internet DNS resolution as appropriate. Now, this is a robust DNS infrastructure, but it had a few things that they wanted to fix. They wanted to be able to stand up stores quickly, and they want to be able to do that without knowing the fixed IP that they're going to be using for those stores. They also wanted to be able to reduce the effort required to maintain this. You can imagine that DNS server software requires developers to go and patch and reconfigure. All of that new IP data has to get loaded in. Those conditional filtering rules have to be updated over time. So post-migration, we see something like this. Just Walkout has instead moved to using access tokens, where they can pre-provision these access tokens way ahead of store build-out and assign them to stores as they come online. They're able to use encrypted DNS to communicate between those stores and Global Resolver via their access token. And that access token maps them to store-specific views for both front-of-house and back-of-house networks, applying the policies automatically with no DNS server software requirement on their end. This is able to deploy to the same 4 regions that Just Walkout has today, but should they choose to go to 5 or more regions tomorrow, they can do that at the flip of a switch on Global Resolver, getting lower latency for clients close to those new regions and additional failover. They saw a lot of really great migration benefits from this. They got enhanced security from the DNS encryption, as we mentioned, a greatly simplified network architecture, support for those dynamic IP addresses where they may not know them ahead of time, and a greatly reduced operational overhead where they don't need to maintain that server software. Next up, I'd like to walk you through a demo. I'm going to caveat that this is a live demo, and we just launched a couple days ago, so bear with me. Hopefully we don't have any problems with the Wi-Fi. So for this demo, I'm going to be walking through a global resolver that I provisioned ahead of time and showing you how this works behind the scenes. I've got some DNS commands over on the right-hand side of the screen that I'll be using throughout the demo. So you can see here our global resolver console, where I've created this demo global resolver. It's currently backed by 2 regions, one in US East 1 and the second in US West 2. Behind my global resolver, I have 2 DNS views. I have an open access view and a restricted access view. They're kind of configured the way that you would expect, where our open view is able to query and resolve kind of whatever, and our restricted access view has some restrictions on top of it. Now for our restricted access view, let's talk about this one first. I've enabled DNS firewall rules to block 2 categories, both travel and shopping. I have one private hosted zone that's doing some custom DNS resolution for globalresolver.com that I'll show off in just a minute. And I have 2 access sources configured. No access tokens, but 2 access sources. One of them is for my very specific EC2 instance IP. And the second one is for the IP range that we're using here at reInvent today. So if you happen to be sitting in the audience and you have a laptop open, you can try a DNS query like this today, and it should go ahead and get resolved for you. Please feel free to try that out as I'm talking if you would like. I'll leave this here for just 1 second if anybody wants to take a screenshot. All right, fantastic. Now, I'm going to be showing DNS resolution from 2 specific instances. The first that I've called IP demo instance has this public IP. you can see here, which corresponds to this same access source that I've configured. Let's go to that one first. And I'm going to have to reload here real quick. Cool. So for this EC2 instance, I should be able to grab one of my sample queries here. And what you can see that I'm doing here is a simple dig or DNS lookup command towards the IPs that were allocated for my global resolver for AWS.com. And I'm quickly giving back those IPs. Hooray! I know you're all very excited to see a standard DNS query. Now, I can also do some more cool things. So let's go ahead and use that private hosted zone that I mentioned I configured earlier. So here, I'm doing a lookup for a TXT record called viewName.globalresolver.com. And you can see when I do this, I get back, I'll zoom in for you, I get back a restricted access view TXT record. So I can prove to you that I'm using the right view. Now, because this is a restricted access view, I have some DNS policies that I've applied. So for example, we're all here in the lovely Wynn Hotel here in Las Vegas. But because I've restricted access to travel as a domain category, that hotel domain is going to be blocked. And I'll show you that here. So as I looked up winlasvegas.com, you can see that I got back this NX domain, which is the response that I configured when I configured my block rules. Pretty cool stuff. So next up, let's talk about our open access view and show off access tokens a little bit. These are going to be a little more advanced because we have to embed the right metadata for the request to be resolved, but we'll show you that here. So no firewall rules on this view. Similarly, I have yet another private hosted zone, no access sources, but one access token. Now for this instance, and I'll reload. For this instance, I have already shared my access token to this host in some environment variables, and I'll show you those here. You can use them while they're active if you like, if you're quick on the screen. But here's my access tokens. So I'm going to head and source these so that they're loaded in. And let's do some more fun DOH and DOT queries. So to start, I will do a DOH query for Amazon AWS.com. I'm going to use KDig, or the NOT version of dig, which is a little bit more advanced and lets me do things like inject EDS0 and do DOH on demand. And so you'll see that here. And hooray, I'm able to issue this DOH query with the very specific, as you can see here, URL or URI that passes in token equals my access token that I configured. And I'm able to get a response back for Amazon AWS.com. If I check kind of the same thing for my view name, you will see that I'm now using the open access view, which I configured in a separate hosted zone for that same DNS name, giving you that split DNS resolution between your two views. The last thing I want to show is a DOT query, which is, again, very similar. But instead of plus HTTPS, it's using the plus TLS flag that you can see, and it's adding this EDNS0 option. 65440 is our predefined access token opcode, and then the open access token in string encoded format here, so that I can do my lookup for Amazon AWS.com again and get back my DNS resolution. So there you have it. We have a global resolver. We've configured a couple of views, and I've shown you how we can use our client-side bits to go and configure those. We do have good examples in our documentation of how you might configure your clients, be they Windows or Mac OS devices, to do those DOH lookups if you're interested in that kind of configuration. I'd now like to hand it back to Adhish, who's going to talk through some of our closing steps.
Thanks.
Yeah, thanks.
Thanks, Matt. Hopefully that was a fun demo. I don't know if you got to try it, but once you're out, you can definitely try it out and let us know what you think. I'd like to also talk about the next steps here. What are the key regions that we are available in today, and also give you a glimpse about the pricing. During preview, we will be available in 11 different regions across North America, Europe, Asia Pacific, and Australia. You can try out the new service in these regions and let us know what you think. In terms of pricing, we will be charging you based on two key dimensions. One is the number of regions that you create, and two is the number of queries or the query volume coming from your clients. We'll be charging you on a base rate for the first two regions combined, and then for every additional region, there'll be an additional charge. For query-based pricing, again, for the first billion queries, there'll be no charge. Everything above 1 billion is going to be charged. The good news is that you will not be charged for price during preview, so you are free to use this service with no additional financial or constraints that you may have. And with that, we have come to the end of the session. Hope you enjoyed it. Do feel free to provide your feedback through your app, and hope you have a great rest of the reInvent. Thank you.